All right, square root of x minus 4. So again, the steps for finding the inverse. Make this into a y. Then swap x and y. So we get x equals the square root of y minus 4. And then we're solving for y. So x squared, if we square both sides, equals y minus 4. And then x squared plus 4 equals y, because we would add 4 to both sides. And so then f inverse of x equals x squared plus 4. Now for figuring out the domain, most of us got through this part just fine. Figuring out the domain happens back up here when we had x equals the square root of y minus 4. Because my domain is x values, right? So this thing here determines my domain. So if there's any value that the square root of y minus 4 will not end up becoming, then that tells me about my domain of my inverse function. So the square root of y minus 4 is never going to be a negative number. And I know the options we had. Here we had x is greater than or equal to 0. And we had x is greater than or equal to 4. So the reason that x is greater than or equal to 4 was tempting is because if we were talking about what values you couldn't plug in right here, or values less than that you couldn't plug in, that would be kind of a tempting one to put, right? Because you can't have a negative number underneath the square root. But remember, this is a y value here, and this whole thing represents the x values. So since this whole square root represents the x values, that's kind of what we have to think about here. So since that whole thing represents the x values, and this will never be less than 0, that's why our domain has to be greater than or equal to 0. Because we're never going to get an x value, no matter what we plug in for y, but, you know, as long as we're plugging in real numbers, it's going to be less than 0. All right. So x is greater than or equal to 0 is our domain here. So anytime you have something like this, the domain of your inverse is going to be greater than or equal to 0. If it's a square root with everything underneath the square root. All right, so that's one kind of example working with domain here. Another one that looks a little bit different would be something like this. On the outside. So instead of the whatever it's adding or subtracting being on the inside with the square root, it's now on the outside, and that does change things when we talk domain. So let's find the inverse here. So y equals square root of x plus 4. Switching x and y, we get x equals the square root of y plus 4. Now, if we're going to pause here and talk about domain. So if we're thinking about domain, this determines my domain. So we have this plus 4 here, and we have this square root of y. Is that square root of y value, what's the smallest that that's going to be? What's the smallest number that the square root of y could end up being? 0, right? Because I can't get a negative number here. So 0, if I had a 0 plugged in here for y, 0 is the smallest that that could end up being. The smallest that can be is 0, and then 4 stays by itself because 4 doesn't change. It doesn't have a variable attached to it. So the smallest that my x values could be is 4. My x values can go all the way off to infinity, but the smallest x value that I have is 4. So my domain is going to be x greater than or equal to 4. Or you could call it 4 to infinity, including 4. So before I solve for my inverse, this would be my domain for my inverse. Because 0 is the smallest value of the square root of y. Okay, so then we would go ahead and solve for our inverse. So I'd add 4 to both sides and get x plus 4 equals the square root of y. And then we would square both sides and get x plus 4 squared equals y. So then f inverse is x plus 4 squared when x is greater than or equal to 4. So that would be our domain restriction. So that's a little bit more about domain restrictions. Any questions so far? Any numbers we're not sure where they came from, or things we're not sure why they happened or how they happened? So kind of the bird's eye view here comparing these two things. We have our first one where f of x was the square root of x minus 4, but it was all underneath the square root. And then when we switched x and y, this determined our domain. So this is a square root is never going to be less than 0. So our domain is greater than or equal to 0. This one, though, only the x is underneath the square root. And we've got this plus 4 on the outside. So that's what shows me that when I switch x and y, the smallest this will be is 0, the smallest this will be is 4, and 0 plus 4 is 4. So that's the smallest value of my domain. So x is going to be greater than or equal to 4 there. Okay. That's a little bit more about domain. Comparing some common ones where they have domain restrictions. Okay, so your quiz is going to be on 1.4 to 1.7. So it's the second half of chapter 1. So let's go back and kind of recap real quick what each of these chapters or each of these sections involve. So let's scroll back to 1.4. All right, now let's take a look at our notes for each of these. Here's our 1.4 notes. It was extrema and average rate of change. So finding your local maxima and local minima by just plugging the function into a graphing calculator and clicking on the points if you're in Desmos, and using the second calc on the TI-81 or 84, I mean, and then clicking on maximum or minimum and locating your maxima and minima that way. But again, if you're in Desmos, you can just click on the points where a maximum or a minimum should be. And then average rate of change. So finding the slope of the line that goes between the 2 points on your interval. And that sort of thing. So if your interval is -1 to 2, you're finding the y value that goes with each of these x values, and then finding the slope between those 2 points for your average rate of change. That was everything from 1.4. 1.5, we had transformations of parent functions. So we had all of our parent functions listed out here that we're going to see. We had all of our linear, quadratic, cubic, square root, reciprocal, absolute value, step function, all those. And then our transformation, so what it looks like to move it left to right and up and down, what vertical stretch and compress looks like, and horizontal stretching and compressing looks like. And then also what reflections over different axes look like. Then we had some examples telling from the graph or from the equation what kind of transformation happened. And then also telling from the function notation what sort of transformation happened. That was 1.5. That was, let's see, and then 1.6, what we did on Monday. We had function operations and compositions. So first we had adding, subtracting, multiplying, and dividing functions, what it looks like to do each of those things. And then we had compositions of functions, so like f of g of x and g of f of x and all that good stuff. So plugging in the g of x function to f, plugging in the f of x function to g. And if you wanted to get evaluated at a certain point, you would plug in the number once you're done. And then also finding our new domain. Sometimes we have to restrict the domain once we combine functions like this. Like if there's an x in the bottom, you have to make sure that you exclude 0 because you can't divide by 0, stuff like that. Okay, so that was 1.6. And then 1.7. Yesterday's assignment, we had the option of a worksheet or an IXL. So if you're, turning this in, if you did the IXL, if you could just stick a comment on there that you chose to do the IXL, if you choose to turn it in that way, that would be great. If you don't, I'll still go and check IXL real quick and make sure that anyone who did it gets it marked off. But if you did the worksheet, please attach a picture of what you did for your work. And our notes, we had inverse functions. So we did a warm-up with what we did on 1.6. And then inverse functions, we talked about the horizontal line test, how to tell if something has an inverse or not. And then finding the inverse, changing f of x into y, swapping x and y, and figuring out the new domain before we solve it. Then solving for y, and changing that into an f inverse of x. All right, we saw a couple different domain restriction types here. We had ones like this, which was like the one that we first talked about, the one from the exit ticket, where the domain is values greater than or equal to 0 or from 0 to infinity, because this square root here, the whole thing's under a square root and will never be less than 0, and things like that. We also had the case where the inverse was the same as the function. That was interesting. Okay, so that's everything that could be covered on your quiz. And the practice quiz is what we're going to be doing today. Okay, and the practice quiz, as do most of our practice quizzes, looks just like the quiz that you're going to take tomorrow. It's just got different, couple different problems and things like that. Got all the kinds of problems that you will see on your quiz. So finding extrema, finding average rate of change, describing transformations, writing a new function that's been transformed, function operations and compositions, and finding inverses. Okay, so that is going to be your assignment for today. If you did the worksheet for 1.7 and would like to see what the answers are, stick around. I will go over the key here. Otherwise, if you did the IXL or you don't want to see the key, then you are free to go and get started on the practice quiz. That's all we've got for today, so there's not going to be anything else, no exit ticket today, just the practice quiz. But if you have questions about anything, feel free to stick around. I'm going to go over the key for the 1.7 worksheet. Okay, so 1.7 worksheet key. You're welcome, Jasmine. Number 1 is no. Number 2 is yes. 3 is yes, and 4 is yes. So that's whether or not they have an inverse. 5, we should have gotten the inverse is x cubed plus 1, and there was no domain restriction for that one. It's just the implied domain of negative to positive infinity. Number 6, you could end up with negative 7x minus 1 over x minus 2, or 7x plus 1 over 2 minus x. Those are the same thing. It's just multiplied by negative 1 on the top and the bottom to get each other. And then the domain, we exclude the value of 2 because you can't plug in a 2 here. 7 has no inverse, doesn't pass the horizontal line test. 8 is x squared plus 2, and the domain is x values greater than or equal to 0. 9, showing algebraically that they are inverse functions. There's 2 different ways you can do it. The first way is to find the inverse of one of them and confirm that it's the same as the other function. So like I found the inverse of f here, and it turns out that it's the same as g of x. Or you can show that f of g of x equals x, and that g of f of x equals x. Either way you want to do that one is fine. Same thing happens for number 10. I go through and find the inverse of f of x, and it turns out that it is equal to g of x. 11, finding the inverse, should get x plus 4 over 2, and there was no domain restriction there. Number 12 has no inverse. 13, we should get 5 over x plus 2, and the domain is x values except for 0. So x is not equal to 0. And then 14, the inverse is the cube root of x minus 4, and there is no domain restriction there. And then lastly, to find the inverse, you switch h and t, and you get 16h squared is equal to the inverse. And so then you plug in 8, and you get 1,024 feet is from the height of the plane, is the height that, from which the plane dropped the water. Okay, any questions on the worksheet? 1.7.
I've got a question on the first problem. I forgot what a extrema is.
Oh, that's for the what's it called? The practice quiz. So basically the extrema are maxima and minima, right? So you want to take this and plug it into a graphing application like Desmos. So I won't type in that one, but let's go x squared minus 2x plus 3. The extrema are all the points that are maxima or minima. So this is the minimum of this function, 1 plus 2, or not 1 plus 2. The minimum value is 2. That would be the only extreme value of this one. If you had a cubic, though, it might have some other extreme values, like this cubic has a maximum here, and it has a minimum here. So the value of the maximum is 3.631. That's my maximum value at that point. And then my minimum value, it's a local minimum, is 0.887. This is a local max and a local min.
All right, thank you.
Yeah, no problem.